Now here we have another problem. In this problem, what we have all the forces on the left side. Okay, that is um, what do we call it? 1 minute. Let's make it full screen. Yeah, now you can see here you have a cantilever being subjected to what? Subjected to 3-point loads. All of them are on the left side. Correct. So now if all of them are on the left side, how do I do now? Let me just go and select a pen. So now what I will do is I will just make it full screen. Now see, first of all I have to select what? First of all I have to just write my sign convention. My sign convention is what? My sign convention is, start taking, let me take it. Okay. My sign convention is, if I just draw it out like this, on the left side, what I have on the left side, I have right side downward is positive, left side upward is positive. Here this is negative and here this is negative. This is for what? This is for shear forces. Downward bending moments are always negative, upward bending moments are always positive, irrespective of right side or left side. Okay. So now here my line is over here and all the forces are on the left side. So all my forces will be what? Downward forces will be negative, upward forces will be positive. Okay, let me just go for shear force. Let me go for shear force. If I want to go for shear force between A and B. Shear force between A and B. This is how much between A and B is downward, left side downward is negative, -3. So what I will do, I will just draw lines like this so that I can do my bending moment and, I can do my bending moment and shear force diagram properly. It's not going, yeah, it's gone. Okay. So I have here, okay. So first let me write it out. This is the line. So between A and B it is how much? -3. It is -3. I am here. Okay. Now shear force between C and D. Anywhere if I am keeping up to this point between C and D, or C on the left side, what are the forces I have got? I have got the forces -3 and then again -1, that is -4. So I have -4 over here. Okay. Then now let me go for shear force between what? D and B. When I say shear force between D and B, C and D, it means the effect of all the forces on the left side. Okay. So what would be this value? This value would be how much? -3 -1, sorry, -3. Let me just put it properly. -3 -1, and then what about this force? This force is acting upward, is it not? 2 kilonewton. So I should write +2. See, left side upward is what it is? Positive, is it not? So this becomes how much? -4 plus 2. That is -2 kilonewton, isn't it? -2 kilonewton. So this was how much? This was -3. This was -4. Now I am having -2 somewhere here. See? So this is what? This is my shear force diagram. You can see here over the length of the beam how shear forces are changing. Okay. Now let us go to bending moment. Let's try to change the color. Now bending moment. So bending moment at A is what? Bending moment. MA is what? MA is equal to 3 into 0, that is 0. So what I will do, I will make 0, that's fine. So somewhere here I need to draw. And it is trying to bend what? It is trying to bend the beam downward. Anyway, first 0 is 0 only. There is nothing like positive 0, negative 0. So you have got 0 here. Then what I will do? Bending moment at C, that is MC. MC if you take, at this point if you take, see, 3 multiplied by 2, is it not? It is trying to bend the beam downward like this. So I will say minus 3 into 2, that makes it minus 6 kilonewton meter. So I am having somewhere over here minus 6 kilonewton meter. Okay. Now let me go to bending moment at. Is there any space here? It's a bit difficult. Yeah. Okay. Then bending moment at D, isn't it? Bending moment at D is equal to how much? Minus 3 into itne zaid, itne, that is arba. Then again minus wahed zarab, how much? Wahed zarab itne. This becomes how much? 12 minus 2 is minus 14 kilonewton meter. So if you come down over here, it is somewhere, this minus 6 minus 14 is somewhere over here. I'm just going like this. Okay, it is going out of the paper, unfortunately. Okay, and now let me come to bending moment at. So let me just write it, do it a bit correctly. So what I will do is I will just rub this one, everything, do it little bit up. Okay, so now I will just draw a line here. It was 0, then it came to minus 6. Now it is minus 14 minus 17. Now bending moment at B, that is MB. Bending moment at B, MB is equal to how much? On the left side you see minus 3 multiplied by how much? Itna zaid talata. 4 plus 3 is 7. Then you have got minus 1 into 5 and then plus 2 into 3. This becomes how much? Minus 21 minus 5 plus 6. Okay, so this becomes how much now? So 1 into 5, that's fine. And then this is 3 into 7, that's also okay. And then here you have got how much? 2 into 3, that is 6. That becomes minus 21 minus 5 is how much? Minus 5 is minus, sorry, so you have how much now? Minus 21 minus 5 is minus 26 plus 6 is minus 20 kilonewton meter. Okay. So you have got minus 20 kilonewton meter. Again, you are going down. That is minus 20 kilonewton meter. Okay. So this is what? This is all your shear bending moment diagram. Understand? This is bending moment diagram. This is all negative here. This is also negative. This is shear force diagram. Okay.